Now, if you want the area to the right of an x value, or you want to calculate the probability that something will be greater than x, well, Excel cannot do that. Excel cannot give you area to the right. Excel could only give you area to the left, which means if you need the area to the right, well, Excel could give you, let's use blue here. Excel could give you this blue area. Excel could give you the blue area because it's to the left of x. And we could use the fact that the area to the left of x plus the area to the right of x together, that has to give you 1 because the total area under the graph is 1. So let's say area to the left plus area to the right equals 1. Okay, so if we want the area to the right, which is the red area here, we could say the area to the right, well, this is equal to 1 minus the area to the left. Okay, so the area to the left is the blue. The area to the right is the red. That's what we want. And Excel here is giving you the area to the left of x. Okay, so this is our rule of complements. We covered back when we were discussing introduction to just the topic of probability. It's one of the rules. We had the addition rule, the multiplication rule, the complements rule. This is the complements rule. And if in the third case, if we want the probability that something will be between x1 and x2, okay, between x1 and x2, which will be this area here. Well, again, Excel can't start in the middle. Excel can't start with the x1 and go up to x2. Excel could only give you all of the area to the left of a number. Okay, so what we could do is we could start with too much. We could say, okay, let me have all the area to the left of x2. So I'll extend the red this way. So all the red is to the left of x2. That's too much area. That's too much. And we can then, okay, so this in red, this Excel function is norm.dist, so that's area, to the left of x2. Okay, so we're working with the x2. Now, we could subtract off. We can subtract off what we don't want. So let's now take this portion that I'm using blue for, everything to the left of x1. Okay? So if we subtract off the blue area, that will leave us with what we want, the area between two x values. Okay, now keep in mind, this is for the non-standard normal distribution. Now, if we're working with the standard normal distribution, or if we're working with z-scores instead of x values, there are three similar, well, there's one similar function that we could apply in the same three ways, to the left, to the right, and between. So if we have the standard normal distribution, which is going to be on the next slide, every standard normal distribution has the same mean. It's always 0, and has the same standard deviation. It's always 1. So you'll see two differences in the formula. You'll see an S. The dot S is for standard. And you'll see no mention of the mean and no mention of the standard deviation. Where in the previous slide, the previous functions, different sets have different means and different standard deviations, so you have to tell Excel what they are. If we're working with the standard normal distribution, we set the functions up the same way. It's the same area to the left, area to the right, and area between two numbers. The difference is we're using the .s, so Excel knows it's the standard normal distribution, and Excel only needs the z-score because the standard deviation and the mean are always the same, mean of 0, standard deviation of 1. I have a separate video where I'll do multiple examples of all 6 of these scenarios. After going through this lecture, the next step should be to my Excel activities I have one video for the standard normal distribution, and I have one video for the non-standard normal distribution where I just do multiple examples on Excel. Okay, so for example, here's an example similar to what you'll see in my other videos. Let X represent the time it takes to download a file image. Okay. Now, we're given, suppose X is normally distributed. All right, that's important. X is normally distributed. So, we know we're working with the normal distribution. All right, we're given that the mean is 18 seconds. The mean is 18 seconds. And the standard deviation is 5 seconds. Okay. We want the probability that an image could be downloaded in less than 18.6 seconds. So we want the probability that X is less than 18.6. All right, so 18.6 is bigger than 18. Less than means we're shading area to the left, which means before we calculate this, we know approximately what to expect. We know our final answer had better be larger than 50%, larger than 0.5, because it's more than half of the normal distribution graph. Okay, so now we have two options. You can always work with X values, in which case you keep the mean and you keep the standard deviation, or you could convert to z-scores. So you could use the non-standard normal distribution, or you could use the standard normal distribution. Okay, so X equals 18.6 or Z equals 0.12. Again, we have our formula for z-score, X minus the mean, so 18.6 minus 18 divided by the standard deviation. Pop that into the calculator, you'll get 0.12. So we could use an X value, we could use a z-score. There's an Excel function for either. So if you're using the table of values, the z-score table, you have to standardize. Obviously, because it's called the z-score table for a reason, it works with z-scores. But if you're using Excel, it's up to you which method you want to use. If you're sticking with the X values, it's the Norm.dist function to find area. And if you're converting to z-scores, it's the Norm.s.dist function. So there's our z-score of 0.12 or our X value of 18.6. Either way, you will get the same answer. Okay. Now, if we're using the standard normal distribution of the z-score table, it looks something like this. There's different variations, but it looks something like this. Now, on the column to the left, this is the first decimal place of the z-score, and on the row on top, this is the second decimal place of the z-score. So this is for negative z-scores. We would have to go to the portion of the table. This is not the whole table, but we would go to the portion of the table that contains the positive z-scores. And you would find, since our z-score is 0.12, the tenths place is a row, the hundredths place is a column, and your answer is where these two intersect. So the probability that x is less than 18.6 is equal to 0.5478. Okay, so we've talked about how to find probability, how to find the area, right? So if you have an x value, you could find the area with the norm.distribution function. Or if you have a z-score, you could find the area with the norm.s.distribution function. Now, we could go in the other direction. If you know the area, you could find the x value, or if you know the area, you could find the z-score. So we're basically doing things in reverse. And I have examples of both of these cases on my other videos as well. Okay, so let's talk about critical values. We're not going to do anything with critical values just now. All we're talking about is the notation. So, and the notation is z with a subscript, where alpha is going to be the area to the right. Now, this is not Excel. This is a statistics notation. Excel only deals with area to the left. But the critical values, the statistics topic, is the area to the right. So what this means is, let's say, for example, z with a little 0.05. Z 0.05. So alpha, in this case, the alpha is 0.05. So what that means is, if we have our normal distribution, something like this, there's some z-score, that separates 95% of the area from the upper 5% of the area. Oop, did not mean to do that. Let's put this back. Having a little problem with the pen here. Okay, so there's some z-score over here. Okay, that's better. That's 0 in the middle. And let's say 95% to the left, and the other 5% to the right. So now we know area to the left, and we know area to the right. So this z-score, z with a subscript 0.05, is referring to this unknown z-score right here. So now we have to go backwards. We've talked about, if you're given the x value, how to find the area. We've talked about, if you're given the z-score, how to find the area. But now, okay, so check. Now we're given the area, and we have to find the z-score. And we could also start with the area and find an x value. Okay, and that's, for that, we will use the inverse. So it's basically the opposite of the distribution function. This is the inverse of the distribution function. Right, so if we have z-scores, there's a .s. If it's x values, there's no .s. And instead of norm.s.dist, it's norm.s.inv for inverse, the inverse of the distribution function. Okay, so an area, the word area is specifically referring specifically to area to the left as a decimal. So for 95%, so in the previous example, 5% to the right. That means 95% to the left, which means the area in the functions up here, this area, is equal to 0.95. Area to the left as a decimal. Okay? And if we plug that into Excel, we would get 1.645. And we could verify that later when we have Excel up on the screen. Okay, so the norm.inverse functions, with or without the .s, give you, so this equals a z-score, and without the .s, this equals an x value. The norm.inverse functions give you z-scores and x values. Okay, we could do one more of these. So let's say the shaded area is 0.9. We have a mean of 63. We have a standard deviation of 2.2. And if we want this number k, what is k? Well, using that using the formula on the last slide, k, if we're using Excel, k should equal norm dot, not .s, norm.inv, because we have an area, we're given the area, and we want an x value. Okay, so the area to the left is 0.9. The mean is 63. The standard deviation is 2.2. Okay. And that should cover all of them. I think that's all 8 we've talked about. Norm.inv, area, area, mean, standard deviation. Area, mean, standard deviation. And that is our value of k. Looks good. It should be above 63 because it's to the right of 63. All right, so last slide, I believe. Yeah, last slide. Here's an overview for reference of the 4. So I have it broken up into 4 sections. 1, 2, 3, and 4. 1, 2, 3, and 4. We have the norm.dist function. Okay. We talked about area to the left, area to the right, and area between. Then we have the standard normal distribution function. And again, left, right, between. And then we have the inverse functions down here in the 7th and 8th rows. If we have an area and we want an x value, it's the norm.inverse function. And if we have an area and we want a z-score, anytime you're talking about z-scores, you need the .s. Z-scores mean you're working with the standard normal distribution. So you always need the .s in Excel. Okay, that does it for this. Next place to go after this video, a good idea would be to watch my other 2 videos, one on examples using the standard normal distributions on Excel, one on using the non-standard normal distribution functions on Excel.